Okay, now we'll see in detail about each and every type of Freidal reaction. As in just now I told you that we have three types. One is called as alkylation, second is called as acylation, and third one is called as carbonylation. So now we'll discuss about these three types of Freidal reactions in detail. Before going into detail, first of all I'll let you know about the reagents of these reactions. We have Freidal alkylation. The reagent for this particular type of reaction is alkyl halide, that is RX. In the presence of, you can take AlX3 or FeX3, or you can use any Lewis acid also. We can also use that ZnCl2 also, that is zinc chloride. Now what actually happen in the alkylation, that how does the reaction actually takes place in alkylation, this we will discuss after I complete the detail of the Freidal carbonylation. So next type of the Freidal reaction we have is the acylation reaction. In this the reagent is basically alkanoyl chlorides, that is RC double bond O Cl, again in the presence of AlCl3, or you can use FeCl3, or you can use ZnCl2 also. So actually how does the reaction takes place over here is that this RC double bond OCl reacts with the AlCl3 and it forms RC double bond O and a positive charge there on the carbonyl carbon, and also we have AlCl4 minus. Now this RC double bond O positive is basically electrophile. So if let us say we have a benzene, so as per the mechanism of electrophilic substitution reaction, what will happen is that the pi electron cloud of the benzene ring will attack on this electrophile, and this electrophile will basically attach on one of the carbon of the benzene ring, and therefore the final product in this reaction, that is over the benzene we have C double bond O and R group. So basically in this particular reaction, again I would say that neither in the benzene nor in the RC double bond O we have the carbocation formation, so there is no point of the rearrangement. So in this case also you would say that the reaction takes place without the shifting of that H minus ion, that is hydride shift, or you say methyl shift, or we might have also that phenyl shift. So next type of the Freidal reaction which we have is the Freidal carbonylation. In this case the reagent for the reaction is basically carbonyl chloride, that is C double bond O Cl2, and how does the reaction actually takes place is that you take again carbonyl chloride, that is CoCl2, which is also known as phosgene. Now we carry out this reaction in the presence of again Lewis acid, which we use as like we have aluminium chloride, that is AlCl3, or we can also use FeCl3 also. So therefore how does the reaction takes place is that AlCl3 react with the CoCl2 and it will form C double bond O positive Cl plus AlCl4 negative. Now this C double bond OCl is again electrophile. So what will happen that aromatic compound will attack on this electrophile and carry out the electrophilic substitution reaction, and therefore if suppose you take benzene as a reactant and you add CoCl2 in the presence of let us say AlCl3, so basically the product formed will be benzoyl chloride, that is over the benzene you have C double bond OCl, and you will be having a H plus as a substitution. So therefore what will happen is that this again H plus will react with the AlCl4 minus formed during the in the mechanisms of the reaction. So it will form AlCl3 and HCl back. So what we can observe over is again that, as in the previous examples of electrophilic substitution, we have AlCl4 minus and we have H plus always as a substituted electrophile. So therefore what happens is that this react with the AlCl4 minus and forms AlCl3 plus HCl. So over here also, like we said earlier also in the previous examples of electrophilic substitution reaction, in this example also we have the strong reasons to say that in this case also the Lewis acid is playing the role of the catalyst. So basically it is accelerating the rate of the reaction. And how is it accelerating? The reason which you can clearly see over the screen, that without AlCl3 or any Lewis acid, there will be no formation of C double bond OCl.